This video is over Lesson 105, Recognizing and Extending Geometric Sequences. So a geometric sequence is a sequence where the ratio of any two consecutive terms is constant. And so we've got some symbols and some formulas here that go along with this. And I've provided two different versions of this. One is the one your book is going to use, and the other is the one that I have seen more often used. So to describe the nth term of the sequence, so just some numbered term out there, we could put a number in there and say the 9th term, the 10th term, or we could just leave it as n, in which case it's just some term out there. Your book writes it as a function form. So a of n is how your book writes it. I have more often seen it written, though, as a subscript, where the n is describing a, which a would then be a value in the sequence. So a sub n. So either way, that works. So the first term, according to your book, should be a of 1. However, for formula purposes, they just use a lowercase a to describe the first term because it is a special term in the sequence, the one that starts it all off. So they just use a lowercase a to symbolize that, or technically it would be a of 1. So in the form that I have seen more often, it would be a sub 1. So we'd replace the n with the 1 since it's the first term. The constant ratio, so remember the ratio is constant. The constant ratio either way is r. But as far as formula goes, how would you calculate that? Well, it's going to be a constant ratio. We take always think final and then initial. So if you want to find change, final minus initial, you want to find a ratio. Final divided by initial. So we have our final, just means the later term. So a of n divided by the initial, the earlier term. So a of n minus 1. So for example, if we chose 7, this would be a of 7 over a of, well, 7 minus 1 would be 6. So the 7th term divided by the 6th term. And it's the same thing over here, a sub n over a sub n minus 1. The formula then, if we put it all together, a of n equals a, the first term, times r to the power of n minus 1. And then very similar over here, a sub n equals a sub 1, so the first term again, times r to the n minus 1. So, ladies and gentlemen, to help us out with this, we're going to take a look now at some practice problems. And so if you would please open up your books to page 708. 708. And here we go. So first up, find the common ratio for the geometric sequence. So A, we have 2, 16, 128, and 1024. Now, sometimes when you've got a comma in here, it can get a little confusing. So is this 2, 16, 128, 1, and then 0, 24? Well, obviously not. So if it ever gets confusing, you can actually turn your commas into semicolons. And so then the semicolons separate the numbers, and then the comma then is just part of your number to separate the place groups. So we want to see if we have a common ratio. So if we do have a common ratio, it's going to be some term divided by the one before it. So that means that my common ratio here should be 16 divided by 2. That should also equal 128 divided by 16. That should also equal 1024 over 128. Now I know 16 divided by 2 is 8. I imagine you probably don't have 128 divided by 16 memorized. So if you grab your calculator just real quick just to check it, sure enough we get 8. And then if I take my, try to get that in the light better, there we go, 1024 divided by the 128, sure enough it checks out. They're all 8. That is a geometric sequence. So they should all be equal. And whatever they do equal, that's your constant ratio. So for B, I have a negative 162 followed by a positive 54. and then a negative 18, and then a positive 6. And I forgot my ellipsis up here. I'm going to throw that in real quick. So, same idea. This should be some term, 54, divided by a negative 162, the term before it. And that should equal a negative 18 divided by the term before it, 54. And finally, that should equal my 6 divided by my negative 18. So now 6 over 18 obviously is 1/3. We know that. And since there's a negative, it'll be a negative 1/3. Well, I can see each one of these is going to produce a negative, so that's good. Now, maybe you have it memorized that 18 times 3 is 54, so that's another 1/3. And then over here, if we think about 54 times 3, well, 50 times 3 would be 150. 3 times 12 would be, or excuse me, 3 times 4 would be 12. And 150 and 12 would make 162. So sure enough, negative 1/3, negative 1/3, negative 1/3. So my constant ratio is a negative 1/3. Letter C, we have a 0.7, followed by a 4.9, followed by a 30, whoop, I accidentally put my decimal in a little early, 34.3, followed by a 240.1. And that goes on and on and on forever. So ellipsis. So again, if this does have a constant ratio, it should be 4.9 over 0.7, which should also be equal to 34.3 over 4.9, which should also be equal to 240.1 over what's before it, 34.3. Well, obviously, if you imagine multiplying this by 10 over 10, this is just 49 over 7, so it should be 7. Also multiply this by 10 over 10 and that by 10 over 10 makes all these whole numbers. Now, if you have your powers of 7 memorized, that would be kind of helpful here because I do know that 7 to the third power is 343, and then to the second power is 49. So third power divided by second power, 3 minus 2 is 1, so 7 to the first power, that's 7. And sure enough, over here, 2,401 is 7 to the fourth power, divided by 7 to the third power. Well, it makes 7 to the first power again. Now, I don't expect you to have those powers memorized. I've just seen them enough times that I've memorized them over the years, and I'm sure many of you will come to that place as well, eventually in the course of your math education. But don't worry about it. If you're not there, you don't need to have that memorized. So there we go. We've proven that they sure enough, they are geometric sequences and found their constant ratios, or common ratios. Moving on to D and E, find the next 4 terms in each sequence. So D, we're going to go 5, negative 15, 45, negative 135. So this time, we're going to go ahead and, since we're not told to find the common ratio, we're going to go ahead and assume that it is a geometric sequence. And I'm going to let you speed things up a little bit. So we're just going to make a mark down here, so R, and just choose one of these. So choose the easiest thing. So negative 15 divided by 5 then should give me my R, so it's negative 3. So if I want the next 4 terms, well, then we're just going to keep multiplying by that negative 3. So I've got my negative 135 times negative 3. So I hit enter, and I get 405. So my next one is 405. Now, little thing about your calculators. Since we're going to keep multiplying by negative 3, what I'm going to do is I'm not going to type anything in. I'm not going to type 405 in. I'm just going to hit times. And so you'll notice here that says ANS. ANS stands for answer. So what's going to happen is, right now, this is going to take the answer to whatever we put in last. So this is going to automatically take my 405, and then I'm going to times that by negative 3 again. So then my next number after this is a negative 1,215. And now this is still what's in the calculator. So if I type it again, hit it again, it'll just multiply by -3 again. So my next number is a positive 3,645. And I'm going to want to use the semicolons here. I'll fill the rest of them in just a second. And now I need one more. So my last one here is a negative 10,935. So I'll make all my commas into semicolons and then circle these four there. E. So E, I'm going to copy the problem, 336, 168, 84, and 42. So if I want to find a common ratio here, I like using the smaller numbers. So I'm going to go with 42 over 84. 42 divided by the term before it, 84. Well, obviously it looks like this is half as much as that, so 1/2. Which I don't even need a calculator then, at least for a few of these. So my first one, well, half of 42 is 21. Half of 21 will be 10.5. Half of that will be 5.25. And this one's probably be a little bit easier if we have a calculator. I mean, you might be able to figure it out. I can. It's 5.625, but still. Doesn't hurt to double check yourself. Or did I say 5? 2. I think I got the 5 stuck in my head. 2.625. So my next four numbers are right there. I'm going to go on to F now. And I got to flip the page here. So F, find the term of a geometric sequence, the first term of a geometric sequence is -3, and the common ratio is 4. Find the sixth term of the sequence. Well, in order to do this, I'm not going to sit there and just keep typing it out. I'm going to use the formula. So my formula here then, if I do it the way the book has it, is A of n equals the first term, -3, times the common ratio, which is a positive 4. Since it's positive, I don't need parentheses around it, to the power of n minus 1. So therefore, if I want to find the sixth term, I'm finding A of 6, and so that'll be a -3 times 4 to the, 6 minus 1 power. So at this point, I would grab my calculator to help me out with this. So -3 times 4, and then this is your exponent button. It's called a caret. Oh, sorry, you can't see it. They're right there. That's a caret. So look how it looks like an arrow pointing up. That's telling you to put your exponent up. So I put that caret in, and then, 6 minus 1 is 5. Hit enter, and so my sixth term is a -3,072. Now, if I were to do this using the subscripts, it would be very similar, but this time it would be A sub n equals a -3 times 4 to the n minus 1 power. And this would just be A sub 6 then, is -3 times 4 to the 6 minus 1, which would still be -3,072. So you can see here, it really makes very little difference. So I really don't care which way you write it, but I do want you to know this is what you're going to see in your book. This is probably more common. Honestly, I can't think of any time outside of your book that I've ever seen it written as a function, but I've seen plenty of times where it's been written with subscripts. Both are very understandable. There's nothing mathematically wrong with this. I just don't think it's as common. So I want you to have the flexibility in your thinking to understand both. All right, moving on to G. G, find the seventh term in the geometric sequence. So I'm going to copy the sequence down. -1/2, 1/8, -1/32, 1/128, and then a -1/512, and on and on and on. So if I want to find the 7th term in the sequence, I would take a moment to find r. In this case, I'm not going to write r as a fraction. I'm going to do it as a division problem. And I'm going to do 1/8 divided by a negative 1/2. And I'm going to put that in parentheses just to make it clear that that's a negative and not a minus. So then if we change that to times the reciprocal, I get 1/8 times a negative 2/1, which of course those simplify. And so this is just going to be a negative 1/4. So therefore, a of n is a first term, negative 1/2 times, and since this is a fraction and a negative, I have two reasons to put that in parentheses, and n over 1. And so since this wants the 7th term, a of 7 will equal a negative 1/2 times a negative 1/4 to the 7 minus 1 power. So when I plug this into my calculator, there's a few different ways that you could do this. So one way would be just to change your fractions into decimals, since they come out as nice decimals. So a negative 0.5 times, and then I will need the parentheses here for that negative 1/4, which would be a negative 0.25. And then we raise that to 7 minus 1 would be the 6th power. So that's pretty tiny. Pretty tiny. And then we can change that to, oh, it's too tiny. It won't let me change it to a fraction. So kind of rethinking this here. We can use the calculator again to help us, but we got to get a little crafty here. So since the calculator's not cooperating, and I want a fraction, I don't want that nonsense there. What I'm going to do instead is I'm just going to consider this is to the 6th power. So we know it's going to be 1 to the 6th power and 4 to the 6th power. So let's find 4 to the 6th power real quick. So 4 to the 6th power gives me a 4,096 in the denominator. And the numerator will be 1. And since we're going to do it 7 minus 1 times, so that's 6 times. So all my negatives will cancel out. And so 2 times 4,096, well, is going to be 8,192. And that'll still be a 1 on top, but it'll be a negative. So if you end up in a situation like that where it just doesn't come out nice and you can't change it to a fraction, by the way, that fraction option I tried to get there, what I did was I hit the math button, and then the fraction option is right there where it should change it into a fraction. And unfortunately, sometimes it works and sometimes it doesn't. So if it doesn't, you just kind of go back to the drawing board. You got to think things through a little bit. All right, moving on to H. Find the 8th term in the geometric sequence. So I've got 4 and 1/4. I have a negative 8.5, and then 17, and then negative 34, and on and on and on forever. So again, I'm going to choose the two that I just think are easiest here. So to find the common ratio, well, I think dealing with whole numbers is easier than dealing with mixed numbers. So I'm going to take my negative 34 and divide it by the term before it, 17. Well, 34 divided by 17 is 2. So my ratio number here is a negative 2. So therefore, my formula, which this time I'm going to do it with the subscripts. Not that it really makes a big difference, but so a sub n is going to equal a sub 1. So that's going to be 4 and 1/4. Now, I'm going to multiply with that, so I don't want a mixed number. So I'm going to think 4 times 4 is 16, plus 1 is 17. So this is really 17/4. And then I'm going to multiply that by a negative 2, which I do need parentheses here because it's negative, n to the power of n minus 1. So to find a sub 8, this will be a 17/4 times a negative 2 to the 8 minus 1 power. So 17/4 is really 1 1/4, so we know that's 4.25 times, and again, I need the parentheses there because of the negative, and then the power 8 minus 1 will really be 7. So multiply that together, and gotta move my calculator over. Negative 544. I find the sixth term of a geometric sequence 40, 32, 25.6, and on and on and on. So when I look at this, I'm thinking easiest thing might be to do 32 over 40. So 32 over 40, I can divide those both by 8, and I get 4/5. So therefore, and we'll go back to the function notation here, a of n is going to equal the first term, 40, times the ratio, which I will need parentheses for that since it's a fraction, and that'll be to the n minus 1 power. So this one's asking for the sixth term in this sequence. So the sixth term will be a of 6 is 40 times 4/5 to the 6 minus 1 power. Now we might be up in a situation like we were in G. The calculator might not give us a nice answer, but we'll just adjust if we need to. So plugging this in, I'm going to have 40 times. Now I could do 4/5 as a decimal since it does come out nicely, but this time I'm going to actually choose to do it more like a fraction just to show you what that would look like. So remember that fractions mean division, so what I could do here is I could really just type 4 divided by 5. And you'll notice that in your calculator, the button for division, oops, gotta move that up a little more. Your button for division actually is the division symbol, but when it comes out on the screen, it comes out with a slash like it's telling you to turn that into a fraction, because they mean the same thing. So if I close that and then raise that then to 6 minus 1 would be the 5th power. Let's see how that comes out. And okay, we get that. Since our third term here was a decimal, getting a decimal answer out does seem to be consistent with that, so that would be acceptable. So my answer then is 13.1072. And J. A fish tank is 9/10 full. Every minute, 1/3 of the water leaks out of the tank. After 5 minutes, how full is the tank? So, well, if every minute 1/3 leaks out, that means that after a minute there's 1/3 that's gone. Another minute later there's 1/3 that's gone. Another minute later there's 1/3 that's gone. So each minute we're basically taking a third away. And so we got to be careful here. We're going to make our sequence, our formula. I'm going to go back to my subscripts. So a sub n is going to equal the first term. Well, we know the first term is 9/10. And this will be times the ratio. And this one's got a little bit of trick in it. You might be tempted to put 1/3 in there. But if you put 1/3 in it, unfortunately you'd be wrong. Because if 1/3 of the water leaks out, how much then remains? How much is in the tank? Well, if 1/3 leaks out, then 2/3 remains. So my constant ratio here is actually 2/3. And that'll be to the n minus 1 power. And n is the number of minutes here. So if we want to find after 5 minutes, well then a sub 5 is what we're looking for. So a sub 5 will be 9/10 times 2/3 to the 5 minus 1 power. So going to my calculator then, I've got 9/10, which I can just do as 0.9, times, and then 2/3, since that's a repeating decimal, I definitely want to write that in there like that as if it were a fraction, because it is. And then 5 minus 1 would be the fourth power. And we'll see if we can get this to play nicely for us. So we get that. We do not want a repeating decimal for our answer. And so I'm going to hope here, I'm going to hit my math button. So remember the math button. So I hit my math button. I'm going to select fraction. And so you see again it says answer fraction. So it's going to turn the answer, the last answer, into a fraction. And hey, it worked out nicely for us this time. So how full is the tank? Well, it is 8/45 full. Eight 45ths full. All right. And, oh, you know what? I gotta take that back. I gotta take that back, actually. So if we think about this, unfortunately for this one, and I knew something was funny when we were setting this up, 9/10 would actually be at 0 minutes. So this actually is not my first term. 9/10 times 2/3 would be my first term, would be 1 minute in. So 9/10 times 2/3, we're reducing before multiplying. And so this is really 3/5. So actually, 1 minute in, my first term, is 3/5. So we do have to take that into consideration, and my apologies for not catching that earlier. But we do have to take that into consideration in real-world problems. So the amount that you start with is usually going to be at time 0. So we need the first term, so that's going to be 1 unit of time in often. So now if I adjust this then, so I can go second, enter, and that will show me what I had last. If I hit second, enter again, it'll take me back to that. And so then instead of 9/10, we got 3/5, which is 0.6. But otherwise everything else is the same. So hit enter. And let's see if we can change that into a nice fraction. Oops. And we can. So actually the answer here is 16/135. 16/135. And now, ladies and gentlemen, we're going to actually go backwards in your book a little bit. I want to take a look with you at example 4. So if we go back to example 4, a ball is dropped from a height of 2 yards. The height of each bounce is 85% of the previous height. What is the height of the ball after 10 bounces? Okay, so again, we've kind of got to think this through. So I can tell you right now that your R is going to be that 85%. That's the constant ratio. Each time it's 85% of what it used to be. 85, 85, 85, 85. So the 2 yards, though, is the beginning height. So 2 yards, let's see, where do I want to put this? We'll put it right here. So 2 yards is before there are any bounces. But 2 yards times 85% as a decimal would be your first bounce. So that's actually going to be your first term there. And so that'll be 1.7. So 1.7 is your first term. So when I make the formula for this, A of n is actually going to equal 1.7 times 0.85. And I didn't need the parentheses there. I could have chosen the dot this time. I just chose it for good measure. So the question is asking what will be the height after 10 bounces. Oh, let's finish that. So then we're trying to find A of 10. And so that'll be 1.7 times 0.85 times 10 to the minus 1 power. Grab my calculator real quick, type that in. 1.7 times 0.85 to the 9th power, because 10 minus 1 is 9. And so that comes out with that big long decimal there. Well, the problem ultimately asks us to round this off to the nearest hundredth. So if we round this off to the nearest hundredth, then we can see that that's going to be 39, and then a 0 will say round down, so just 0.39. So approximately equal to 0.39, and the units were yards. So real world problems, remember to find your first term. So the number that is there before anything has occurred is in some ways like your 0th term, if you will. So you'll have to think through, what would this be? 1 bounce in, or in the case of letter J, 1 minute of leaking in. So that would be your first term, 1 minute in or 1 bounce in. And that, ladies and gentlemen, is our lesson.